Let us study the operation difference. Okay, so let A and B are two sets. Then the difference of set A and set B is the set of all those elements of set A which do not belong to set B. Okay, as we know that if we operate between two or more sets, then what we get is also a set. Okay, so the difference of two set is also a set which is the elements of set A but not present in set B. Okay, and we denote it by A minus B. Okay, we give this symbol. This is for difference. Okay, A minus B. So how can we write it in set builder form? We can write it as follows. Okay, A minus B equal to x such that x belongs to set A but x does not belongs to set B. Okay, then what will be B minus A? Are the both same? No, they are not same. B minus A is defined as x such that x belongs to B but not belongs to A. So we can say that if there are two sets, let A and B are the two sets, then A minus B is the set where the elements are the elements of set A but not of set B. Okay, whereas B minus A is defined as the set of all elements which belongs to set B but not belongs to set A. Okay, if A is any set where the elements are as follows, and B be another set where the elements are like this. Okay, so what will be A minus B in this case? A minus B equal to, here you have to see that in case of A 2, 4, 6, 8 and 10 are there, and in case of B the elements are 2, 4, 5 and 7. So we can clearly see 2 and 4 are the common elements between A and B. But the extra element that are present in set A but not in set B are 6, 8 and 10. Hence A minus B will be the set of elements 6, 10 and 8. Okay, but B minus A equal to, it is a set where the elements are 5 and 7 because 5 and 7 are present in set B but not present in set A. Okay, now we will see how can the difference be expressed in Venn diagram form. In Venn diagram form, we can represent the operator difference in two different ways. Okay, first one is for A minus B and the second one is for B minus A. Okay, let this rectangle represent the universal set U. Okay, and A be a set and B be another set. Okay, let this is A and this is B. In this case also there are two sets, let A and B. Okay, so A minus B will be this portion. Okay, this portion. That means this is the region for set A, but this region does not belong to set B. Okay, we will not include here this part. This part is A intersection B, and if we take A intersection B, we know that A intersection B is a subset of set B also. So we will exclude here the A intersection B part from the set A. Hence this will represent A minus B, and similarly here this region will represent B minus A. Okay, so now the question is, what if A is a subset of B? Okay, in that case what will we do? In that case A minus B will be equal to 5. Okay, A minus B will be equal to 5 because if A is a subset of set B, then every element of set A is also in set B, and hence there are no extra element in set A which are not belongs to set B. So we say that A minus B will be 5 in that case. Let A be a set where 1 and 2 are its element, and B be another set where the elements are 1, 2, 3 and 4. Okay, in this case you can see that A is a subset of B, hence A minus B will be equal to 5 because here no extra elements are there. 1 and 2 are also belongs to B, but no extra elements are there in set A, hence we will say that it is 5. Okay, that's all for difference. Now we will study the next operation, that is symmetric difference. So we have studied already about the operations union and intersection and also difference. So what is symmetric difference now? Symmetric difference is, we can say that it is a combination of the operation union as well as difference. Okay, let A and B are two sets. Then the symmetric difference of A and B can be defined as A minus B union B minus A. Okay, we have studied the difference, that is A minus B and B minus A, and we also know that A minus B is not equal to B minus A. So what we will do is, if there are two sets given, that is set A and set B, then we first have to find out the value of the set A minus B, and then we will find out B minus A. And if we will take the union of both the set, then we will get the symmetric difference. Okay, this triangular symbol represents the symmetric difference. Okay, how can we represent it in set builder form? It can be represented in set builder form as follows: X such that X belongs to A minus B, or X belongs to B minus A. As we know that in case of union we use the word or. Okay, so this will be the set builder representation of the symmetric difference between two sets. Okay, so let us take an example. Let A be a set where the elements are 2, 4, 6 and 8, and B be another set where the elements are 2, 4, 3, 5. Okay, so here A minus B will be the set having the elements that are present in set A but not present in set B. So what are they? They are 6 and 8. So we can write here 6 and 8. And now B minus A will be the set that is having elements that are present in set B but not present in set A. So they are 3 and 5. Okay, so now the symmetric difference will be the union of this set and this set. So how can we write? We can write it as like this. Okay, this will be the symmetric difference. So what will be the Venn diagram representation of symmetric difference? We can represent it as follows. Let this rectangle represent the universal set. Okay, and let this is set A and this is set B. Okay, this is set A and this is set B. We know that this region is A minus B. Okay, and this region will be B minus A. This is A minus B and this is B minus A. So the union will be the given shaded region. Here what we are doing is, we are excluding the A intersection B part from the A union B. Okay, so this is the representation of the symmetric difference between A and B. Okay, I hope this is clear to you. Now we will study the complement of a set. So the next operation is complement of a set. Okay, so first, what is its definition? Let U be a universal set. Okay, let U is universal set. Then we know that if A is a set, then it is a subset of its universal set. So A is a subset of U. Okay, then the complement of A denoted by A dash. Okay, A dash, or we will use superscript as C. Okay, in both the way we can represent the complement. then A dash or A complement is set of all elements of U which are in U but not in set A. So we can write it as this equal to the difference of the universal set and the given set. Okay, so we can write it U minus A. So what is the difference between other operations that we have studied till now and the complement? The difference here is we are just using one single set. Okay, this is the operation that operates on a single set, whereas in other operations we need multiple number of sets to operate and to get a different set. Okay, so how can we represent it in set builder form? In set builder form we can write it as A dash equal to x such that x belongs to U but x does not belongs to A. Okay, let U be an universal set where x such that x is an animal in a forest. Okay, let U be a set of all animals present in a particular forest. Okay, and let A be a set where x such that x is a tiger. Okay, here we can say that there are so many types of animals in the forest and A is one among them, that is the set of tigers. Okay, so there are so many animals, let's say bear, lion or anything else. So what will be the A complement? A complement will be every elements or every animals but not the tiger. Okay, so A complement can be defined as x such that x is not a tiger in the forest. Okay, we can say that A complement is the negative form of set A. Okay, except A, everything comes under the A complement. Okay, so if I take another example, let A equal to the set of all even integer. Okay, then in this case the universal set is set of all integer. Okay, so what will be the set of A complement? In this case A complement will be defined as the set of all odd numbers. Okay, in this case we can define it as set of all odd numbers. Okay, because the union of the even integer and odd integer is the set of integer. Okay, so another property we can write it here as A union A complement is equal to the universal set. So the union of any set and its complement is called the universal set. And what will be A intersection A complement? What is the common element between A and its complement? It is clearly pi, because if a set is of all elements of even integer, then any element we pick from here that will not be a odd integer. So we can say that the intersection of A and its complement is always pi. Okay, so now how can we represent the complement in Venn diagram form? Let this is the universal set U. Okay, this is the universal set U and this is a set A. Okay, this is the set A. Then except A, everything is the A complement. Okay, so you can highlight all the part of the U that are not belongs to A. So this will be A complement.